Okay, here we are at the lesson practice. And these lesson practice problems actually call for us to go back to the examples in lesson 22 and view the graphs. And what I did was I just copied all of the graphs down below. Now, if you want to see these a little bigger, feel free to follow along in your textbook and actually use the graphs in your textbook so you can see them a little more up close and personal. Here, they're all here, but they're not the biggest just because it's hard to make them as big as we would like and fit them all in. All right, letter A. Use the double bar graph in example 1. What year shows the greatest difference between number of shops Sal and Harry owned? Okay, so here's Sal's Deli and Harry's Deli. I notice over time, Sal is acquiring more sandwich shops and then losing sandwich shops. Harry's continues to grow pretty steadily over time. I don't know what happened exactly, but Sal's business seems to be declining. Harry's business, maybe he just has a meaner sandwich. All right, so what year was there the greatest difference between the number of sandwich shops? Well, it's either going to be the first year or the last year, and I'm just looking at the height of the bar. Notice that the difference between bars goes up 3 segments on the 2001. 2006, it goes up like 1, 2, 3, 4, 5.5 segments. So definitely the answer to letter A, just by analyzing the graph, is 2006. Letter B, use the double line graph in example 3. That's this graph right here. What was the greatest number of shops Sal opened in 1 year? Okay, so here we're seeing a trend over time. The number of sandwich shops that Sal has, that he's the filled in circles, and Harry, these are the square circles. Now what this shows, notice the difference between this and the bar graph. They're very similar to each other. The peaks of these lines are exactly the same as the bars, okay? But what this shows is that there's a trend over time of this increasing. Like it shows the increasing and decreasing trends a little more clearly. All right, so let's take a look here. The double line graph, what was the greatest number of shops Sal opened in 1 year? Okay, so Sal, remember, is the filled in circles. The steepest line, oh, that's kind of nice. We can see how steep the line is to see how different the number of shops he opened. The steepest line is here. So this would be the greatest number of shops. And it went from what looks like 9. See, it's halfway between 8 and 10. So 9 up to, let's see, 12, 13, 14. From 9 to 14, that's 5 shops from 9 to 14. Letter C. A stem and leaf plot. Okay. Make a stem and leaf plot of the data showing the height in inches of grandchildren in the Jackson family. Now, what I'm going to suggest for this is start by rewriting the data in order from smallest to greatest. It's going to make your life easier. So I see 43, and then the next smallest number is 49, and I have 2 49s. Oh, I forgot a 40. I see a 40. So I'm going to add my 40 at the beginning, okay? So I've got 40, 49, 49, and 43 taken care of. All of my 40s are done. Let's see, 50s, I have 52 here. 54 got printed down on the next line. Don't forget that one. And then 56, okay. Let's see, so I have all of my 40s. 1, 2, 3, 4 40s. 1, 2, 3 50s, I got those. 60s is just 68. And then 70s are 71, 72. All right, so I have a total number of data points. Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Didn't miss any. Bam. All right, now the stem and leaf plot. The actual stem and leaf plot. Here's what I'm going to do. I'm going to take this and I'm going to copy it. And what I need to do here is I need to make a display that shows each of the highest place value numbers. So I see I have 4s in the 40 range, 5s in the 50 range, 6s Let's see, 1 6 in the 60 range and a couple of 7s in the 70 range. I don't have any 1s, 2s, and 3s. So none of the grandchildren had heights in the 10-inch range, 20-inch range, or 30-inch range. And I don't have any 8s. So nobody had a height in the 80-inch range. So this is what my stems are going to look like. Okay, so this is how you do it. And then what we're going to do is over from the stems, I'm going to look at all of my 40s, 40, 43, 49, 49, and I'm going to write each of the digits that's after the 4 as a leaf. 0, 3, 9, 9. Okay? For 5s, I'm going to do 2, 4, 6. For 6s, I'm going to do 8. There's only one. It's an 8, 68. Okay? And for 7s, I'm going to do 1, 2. This is my stem and leaf plot. Okay, so do you notice what I did? And then we should put a line, a vertical line right here. Separate everything. All right, perfect. And that is what my stem and leaf plot is going to look like. That shows me that most of my data is in the 40s and 50s. And I have fewer data points up in the 60s. I only have 1 in the 60s and 2 in the 70s. So I kind of get a count of how spread out my data is and where my data is concentrated by looking at a stem and leaf plot. So that's all it's doing. It's like almost like a sideways bar graph showing me how many of my data points are in the 40s, how many in the 50s, how many in the 60s, how many in the 70s. You're going to be making lots of stem and leaf plots. So sorry if it's kind of tedious to do, but get used to it because it's something that will be coming up again and again. All right, letter D. Use the data in example 4. Which month shows the greatest difference between deposits and withdrawals? And again, I'm looking for the month that has the greatest difference between the two bars. May is pretty big. January is pretty big. Which one's bigger? Well, the difference between May deposits and withdrawals is $300. The difference between January's is $1, $2, $3, almost $400. So January definitely has the bigger difference. And then lastly, this one's the hard one. Use the circle graph from example 5, this graph right here. If the first quarter sales the next year are $3 million in the first quarter, predict the sales for the year. Well, only 12% of the sales are in the first quarter. So if I was going to predict the rest of the sales for the year, and I know that 12% of them are in the first quarter is 3 million, here's what I know. 12% is 12 over 100, right? 12 over 100 times the total sales for the year, I'm just going to represent that with Y, equals the total sales in the first quarter. So 12 over 100 Y equals 3 million. I have to multiply 12 over 100 times something that's going to get 12 over 100 off of this side. So what I'm going to do that is I'm going to multiply this by 100 over 12. And then I have to multiply the other side by 100 over 12. Okay? And if I'm representing this number the best way I can, I'm going to just put some commas in it to make it look like 3 million. So what I need to do, this is going to get rid of this value over on the left that's multiplying Y, because I multiplied by the reciprocal. And it's going to change 3 million into the yearly sales, because I'm getting Y in a side by itself. That's the answer. So for an answer, I'm going to put $25 million. Okay? Once again, how did I get that? Well, I know first quarter pie is 12% of the total. So what I did was I took 12% of the total for the year equals what was given in the problem as a total for the year, 3 million. Now to solve for the year, I just get Y on a side by itself, 25 million. That is how we do it. Alrighty, now you know how to use graphs, how to interpret graphs to get the data that you're looking for. For next time, you should be able to work lesson 22, 1 through 30.